Personal finance practice problem using Excel. Present value and future value mathematical formulas. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're down here in the Practice tab as opposed to the Example tab. The Example tab, in essence, being an answer key. We have the information on the left-hand side. We're going to populate that into the blue area on the right-hand side. Before we do, however, we're going to unhide some cells. You may or may not have the cells hidden on your worksheet, but we want to practice hiding and unhiding cells because that can be a useful skill as we maneuver around an Excel worksheet. So you'll note in this Excel worksheet, we've got A, B, C, and then it skips like to R over here, meaning missing letters in there. That's an indication that there's hidden cells. So we're going to unhide these columns in between by selecting the columns around it. So I'm going to put my cursor on column B so I see this drop down. Left click and then drag over to column R, let go, and then right click on that selected area. And then we should see something down here saying unhide. I'm going to unhide those columns so we can see what we did last time and continue on with our worksheet. So the problem says we assume the value of property increased at a rate per year of 7%. Now, this would be a similar kind of scenario if you're talking about any kind of thing that's going to increase, like an investment, like a house, like land, like stocks or something like that, that you expect to be going up over time. We're going to be asking how long it will take before something doubles. So you could ask that with an investment amount like $1,000, or you can ask it abstractly, just basically saying how much would any investment take to double at a rate of 7%. You can find the answer using our rule of 72, which is kind of an approximation we did last time. We got to the 10.29, which is a great strategy, but it's restrictive. We then did our calculations with regards to a running balance table and found that it was somewhere between 10 and 11. We could get more detailed than that, but just to show how you could do it that way, this is actually very useful because it gives you more detail about what's actually happening on a year-by-year basis or period-by-period basis. Then we looked at it with regards to formulas in Excel. This is probably the method that you would use most actually in practice. It's the most practical kind of method, although you want to use it in conjunction normally with the running balance table because this will give you more detail. And then now we're going to be looking at it with regards to our formulas here. So now we've got our formulas for the present value calculations, and we want to look at it from a mathematical standpoint. Now, the mathematical standpoint is probably oftentimes when you learn these kind of things in a classroom, the thing that they start off with, but it's also the thing that's most least likely to actually you're going to use in practice because you're probably going to be using Excel and the functions in Excel or a financial calculator more and more, possibly using the Excel. But of course, the mathematical formula can give you a conceptual idea of what is going on in the calculation. They can also give you an idea algebraically how these formulas are related when you're looking at a future value and a present value calculation. Now that's where we stand. Now I'm going to go back. Notice that we've repeated in the worksheet the data over here. So you don't really have to, in that format, hide cells. But I'm still going to go back and hide the columns again, just to get an idea of how that can be useful to see your data if we only had like one set of data over here on the right-hand side. So what I'd like to do is I'm gonna hide everything from column D on over to where we're working, which is column M. Also note that you can increase or decrease the size of the screen down here. So I'm going to make it a little bit smaller. It's now at 180 on my screen, and that's another way you can kind of move around these Excel worksheets. So we're going to say, all right, let's go from column B or column D over here. I'm going to put my cursor on column D, select all the way over to then, let's go to column N, D to N, let go, right click on those cells and hide them. Now, you're not required to do that because you'll still see the information over here if you don't do that, but I'm going to go ahead and do that. I'm actually going to hide then from A to C so I can just keep the data that's in column O. Let's keep the data there. I'm going to go ahead and hide that as well. So now I'm just working in column O on to the right. And like I say, you don't need to hide them. You could just work in the worksheet from that point forward. but just so we don't get in confusion, it can be useful to use that hiding. Okay, so we have the calculation down below. This is going to be the present value calculation, which equals the future value of 1 over 1 plus r to the n. Now note what we're looking for here is actually the number of periods. So we saw when we did the functions that you can actually kind of use a different function and use it in a similar way as algebra to solve for the number of periods, or you can use your present value and future value. Now, these two formulas, present value and future value, are related, and they both have this number in it, which is going to be the number of periods. So you can then use either of these formulas, solve for the unknown, which in this case would be the number of periods, with it. So when you're thinking of a problem like this, note that you could do it one way. You could kind of try to think of another formula that would be solving for the number of periods. But most likely, if you were to do this mathematically, that's not how you'd go about it. You would think of the present value formula or your future value formula, plug in everything that you know, and then solve for the unknown, basically using your algebra. So how that might look, if we look for our data up top, we know what the percent is. We know what the investment is, the starting point, which would be the present value, and we know where we want to be at the end, which is double that, or 2,000. So if we were to plug this into our formula down below, it would look like this. We'd say that the endpoint should be this. It should be equals to the 1,000 equals the future value. That's where we expect to be. That's where we want to be at the end of this process, which is double where we started at, 1,000 times 2, or 2,000. I'm not going to put an equals in front of it. 1,000. This equals the 2,000. And then I'm going to put brackets around this. This is going to be, let's just say, times. And then we're going to say 1 over, and then it's going to be 1 plus the rate, and the rate is going to be that 7%. So we could say 0.07, and then this would then be going to the power of shift 6, and then n would be the unknown. So it looks something like that. And then, of course, we can solve for the unknown of n. And you can do the same thing for the future value formula, which would be the future value equals the present value times 1 plus r to the n, the number of periods. And you can plug that in here by saying, all right, well, I know the future value needs to be 2,000, and that would be equal to the present value, which needs to be 1,000. And then we'd say times, and we'll say 1 plus r, which was that 0.07, and then to the power of n, which is the unknown. So once again, we're left with that one unknown of n in either formula, and then we can go in and solve for that unknown in this instance. So I won't do the algebra here. You can work through the algebra yourself. What I would like to do here is then take this formula and put it into a table type of format. That exercise in and of itself can be quite useful because oftentimes it's useful to put something into this type of format as you're working with tables and different types of scenarios. And then we're going to see that goal-seek activity working again in possibly a more familiar format where you're looking like at an algebraic problem, which we will solve not by working the algebra for n, but by using that trial and error method, hopefully giving you a better understanding of how we would use that kind of feature in a function type of format as we did in the prior presentation. So let's go ahead and try to build a table based on this formula. Whenever you have a formula like this and you're building basically a table on it, you're kind of thinking, you're basically taking an algebraic formula and building something that looks more like a tax return, right? You're trying to put it into cells, and that can be quite useful for problem solving. It's another way to visualize the problem. And again, it's another way to build kind of scenarios and just work on your Excel tables. So basically what you want to do is, usually if I was to put this into Excel, I'd like my outer column to have the end result of the numerator and the denominator, and any more detailed calculations I'm going to have on the inside of the calculation. Also note that whenever we take something like the future value over or times 1 over something, you can rewrite this as just the future value over 1 plus r to the n, which is going to be the calculation. So if I bring this up top, I'm going to say, all right, well, the future value is basically the numerator. So I'll say, let's start off with the future value here, and that's going to be the known amount. That's going to be equal to the 1,000 times 2. And notice I'm doing this with a function. I'm going to put that in the outer column because that's basically the numerator. And I'm going to pull my data as much as possible from the data on the left, just practicing good Excel skills here. So I'm going to say this is going to be equal to the 1,000 times 2 instead of just hard coding or typing 2,000. Now then we have the denominator. So I'm going to go ahead and kind of try to label what I'm going to do down below by putting this 1 plus r to the n. And that's going to basically be what I'm going to pull into the inside, kind of a subcategory that we will have in our calculation until we get to the end result, which will be the whole function of this denominator that I'm going to pull over to the outside. So I'm just going to simply say, I'm not going to label the 1. I'm just going to bring that 1 over here and say 1. And then I'm going to say adding the rate. So we'll say the rate is going to be the 7%, which once again, I'm going to pull from my data as I build my table. So I'm going to be pulling that from the 7%. Notice that in our table, it is now in there as a 0 because it doesn't have any decimals or percents. I'm going to go to my Home tab, Numbers group. You could add decimals to get to the 7%, or you can make it a percent, moving the decimal over automatically and adding the percent sign to it. So there's our percent. Then I'm going to underline that by going to the Home tab, Font group, and underline. And that's going to give us, I'm going to call this just a subcategory of 1 plus r, which is going to be, now here I can do this way. I can say this equals this number, the 1, plus this cell here, which is going to be the rate. Let me do that again. Hold on a second. Something funny happened. This is going to equal to the 1 plus this plus this. So S4 plus S5, or we can use our sum function here. So let's use our trusty sum function. And if you don't know the sum function, most useful function is equals SUM. We're going to use it all the time. It's just adding up a column, usually a column or some series of numbers. And then we're going to add the sum of this to here. So there's our trusty sum function. Adding that up. Once again, it's not in the format that we would like to see it in, however. So I'm going to go to the Home tab, Number group. We can add decimals to be at the 1.07, or we can make it a percent, which is I'm going to prefer the percent at 107%. So that's going to give us then the value of the I'm going to call it 2n periods. So the number of periods, which is going to be this n here. So that's the unknown. We don't know what that is. And I'm not going to rework my table in order to figure it out. I'm going to use the same method we looked at last time. I'm going to say, let's guess what it is first. And then I'm going to go down here and rework this, change this number that we're guessing to get closer and closer to the right answer. Then we'll use Excel to use that same method called goal seek to find that answer exactly. So I'm just going to choose like 5 here. And then I'm going to use that cell. Instead of hard coding 5, I'm going to use this cell to populate that 5 up top. Now, because that cell is really the cell that we're guessing on, that we're going to be changing, I'm going to make that yellow by going to the Home tab, Font group, and making it yellow here with the yellow bucket. And that's going to give us then the total denominator, which you could just call denominator. I'm going to say 1 plus r to the caret n periods. Let's say periods. And that's going to be, I'm going to bring this to the outside, which of course is the whole denominator now. That's the whole denominator. So I've got to bring this to the caret. Now it's a little bit like, how do I take something to the power of when it's in a computer or in Excel? It's going to be equal to, I'm going to point to this 107%. And then you got to go Shift 6. That caret right there, Shift 6 on the keyboard is to the power of, and then point to this cell, which will be 5. So S6 caret S7 and enter. And once again, we got to add some decimals possibly here. So I'm just going to add decimals. So there we have it. So let's keep it there. I'm going to add a lot of decimals just so I can get more detail in the answer. Notice it doesn't matter how many decimals you show. Excel actually has the real number going on to whatever infinite number of decimals or however many decimals Excel can handle, which is a lot. So then we're going to go up top to the font group and underline. And then that's going to give us our present value calculation, because now we have the numerator and denominator in the outer columns, I'm going to divide this out. This equals the numerator divided by the denominator. So this divided by this, and so we're going to say enter, and there we have it. We might add a couple decimals by going to the home tab, number group, couple decimals here, and there we have it. Now this kind of table can be useful because then you can kind of adjust your calculations on the left and in Excel, and you can run different scenarios that way. So what we are solving for is actually this number of periods here. And so notice we could do this algebraically. If we wrote it out this way, we can then solve for n algebraically, or we can kind of use trial and error. And this is the concept that we used when we used the Excel functions. That's why I think it's relevant to take a look at here. So we can then change the cell and say, okay, I need this end result to be 1,000. So what if I change this 5 to 6? What if I change it to 7? And so on and so forth. And then I can ask Excel to do that method for us using that goal seek again. So I'm going to ask Excel, and let's change it down here. I'm going to say this equals the 5 again. I should have changed this number down here to 6 to 7. And that changes the cell up top. So I'm going to ask Excel, would you change this cell, this data input cell, to whatever number it needs to be to make this number be what I know it should be, which is 1,000, that then getting us to the end result without using the algebra instead of solving for n, in other words. We're basically using the algebraic concept of having one unknown, but just basically forcing it to work through trial and error and having a computer do that trial and error for us. So I'm going to put my cursor off the cell. I'm going to go to the Data tab up top to do this, to the Forecast, the What If analysis, and the Goal Seek. And then we're just going to say, okay, Excel, would you please set this cell to be, the end result should be 1,000, because we're looking to the present value to pull that 2,000 back to 1,000. So this needs to be 1,000. We want you to do that by changing this cell, the data input cell, to whatever it needs to be to make that the end result that it should be 1,000. So we're going to say OK. And so there we have it. So now I'm going to say OK here. Add a couple decimals because it should be 10.24. So I'm going to go to the Home tab, number group, couple decimals, and there we have it. So hopefully you can see if you had a long formula or if you're using functions where you cannot do the algebra, then you can see how this goal seek kind of method could work if you set up your table and then you're kind of solving for basically some kind of unknown situation. Now we can do the same thing for the future value calculation over here. So the future value calculation is the future value equals the present value times 1 plus r to the n. Let's do our same thing, building a table from this, and then we'll have the unknown, which is n, which we'll populate here. Then we'll use our goal seek to find that number. So this is the same kind of thing. This time I would like the present value and this whole outer section to be in the outer column. And then I'm going to pull any subcategories like this 1 plus r to the n into the inner column. And that's how you can set up your table, kind of like a tax return type of table to set up so that you can then put your data input possibly a little bit easier depending on what your workflow is and what you're working on. So let's start off with the present value then. Present value is going to be, I'm going to put that in the outer column. Present value, I'm going to put that out here, and that's going to be the 1,000. That's where we are at the start. And where do we want to be at the end? 2,000. That's where the future value is going to be. So then I'm going to say the denominator. I'm going to put this in there with a colon so we can see that it's going to be a sub-calculation of this whole thing. This isn't the denominator. This is the other thing we're multiplying by in this case. 1 plus r to the n. So I'm just going to put 1 here. The rate is going to be 7%. This is going to be equal to then that 7%. Notice I'm not just hard coding or typing in 7%. I'm going to pick it up from our data table. And then we're going to go over, I'm going to make that go to the home group, number group, home tab, number group. We could add decimals, 7%, but we would like to make it a percent by selecting the percent item. We would like to underline it by going to the font group and then underlining it. And then that's going to give us our 1 plus the rate, I'll have for the subcategory. You could do this by saying this equals the 1 plus the rate, or Z4 plus Z5, or deleting that, use the trusty sum function, which you want to be able to see when you're going to use that and use it most often because it's the most common function, equals the SUM of these two functions. This is by far, by very far the most used function that you should, everybody needs to know that if you do anything in Excel. And then we're going to go up top and go to the Home tab, number group, adding a couple decimals. There's our 1.07, or we can see it in the form of a percent, percentifying it. So there we have that. And then that's going to give us to the end periods. So we're going to take that to the end periods. So we're taking that to the end periods here. That's our unknown. We don't know that. So I'm going to go down here and guess once again. Let's put our trusty 5. That's going to be our guessing point. Then I'm going to take that from my data equals that 5 and enter. I'm going to make that yellow because that's going to be our focus point. Fonts group, making it yellow. We will then adjust that after we do our calculation. And that'll give us then our rate. We're going to call this 1 plus the rate, shift 6 to the n, periods. And you can also, so that's going to be on the outer column here. So this is going to be equal to the 107%, which is in Z6, shift 6, or caret, to 5 periods, 5 years. And enter. There we have it. I'm going to underline the 5 before I forget. Font group and underline. I'm going to then adjust the calculation here by going to the Home tab, number group. You could add decimals. You could make it a percent. Let's just add decimals so we could see multiple decimals here. Excel will calculate the decimals whether you show the decimals or not. So no matter, even if this cell was only showing 1, it still really is not 1 if you calculate with it. It's going to be including those decimals. Really need to know that when you're working with Excel, or it will confuse you. And so then we're going to go to the outer column, and we'll multiply these two out because now we have these two components in the outer column. So this is going to be the 1,000 times this decimalized number we came to. There we have it. Let's add a couple decimals here by going to the number group, picking up a couple decimals. There we have it. Now, this time, this end result here, we know should be 2,000 because it's the future value, and we want it to double because that's the question. When is that going to double? So we need to be changing then this period here, which we could do by solving algebraically, or we're going to use the goal-seek method to kind of use that same concept of having one unknown, but instead of reworking the problem, simply use trial and error to make it work, and then use Excel to do the trial and error quite quickly with the goal-seek feature. So in other words, I could just change this cell and say, well, what if this was 6? What if it's 7? What if it's 8? And so on until I get up to 2,000, or I can ask Excel to do that by then going to the Data tab, going to the Forecast, What If Analysis, and then the Goal-Seek tool. We're going to say, Excel, would you please set this cell right there to be the end result we know it should be, which is 1,000 times 2, or 2,000, future value, and then by changing the data input for the number of periods, which is in this cell, the 8. So change this cell to whatever it needs to be, which will change this cell, which will then change this cell to what it should be, which is the 2,000. So we're going to say, okay, and then Excel just does it really fast. That's what Excel does. So there we have it. And then I'm going to add a couple decimals up top here. Let's go to the Home tab. Let's add a couple decimals here. So there we have it. So that's it. That's useful skills to basically have. Now, these skills that we have setting up tables may not be as useful for test-taking skills, where they're just going to give you a piece of paper and a pencil. But in practice, this kind of skills, hopefully you can see how they would have value. And when you're looking at more complex situations, understanding how to set up a table, understanding how to basically pull that information from a set of data, understanding how to basically be able then to adjust this set of data, and looking to see how to use a goal-seek feature to solve for an unknown function or component can be quite useful, especially in circumstances when you're looking at a scenario that's a bit more complex than something that you can just solve algebraically, or even this equation is getting to the point where it's, it's a little difficult to solve algebraically. Let's go ahead and format this a little bit more while you're here. Notice that this colon has a subcategory kind of calculation. A lot of times then you will indent the inner columns just to make it look nice. And this is the end result over here. So what I'm going to do is I'm going to select from the rate down to this period. I'm going to go to the Home tab up top, Numbers group. Let's increase the indenting. So notice I can increase the indenting without double clicking in it and like spacing it out. that way, so it's all uniform in that way, and you can give it a nice little look. I'm going to indent this one more time because I pulled this into the outer column. So I'm going to go to the Home tab, Alignment, and indent that again. So there we have it. Now you got this colon, means there's a subcalculation. That means we're pulling it into the inner column. These are indented, and then this is the subcategory or end of that subcategorization, which has now been pulled out to the outer column again. Let's put a bracket around here, bracket around that. Okay, let's do that same thing on this one. So we're going to say, all right, this is the subcategory. All these cells then are going to be indented to indicate that it's a subcategory, also indicated by the colon, by going to the Home tab, Alignment, Indent. And then this is the end of that subcategory that we put out into the outer category, which I'm going to indicate by a double indentation, Home tab, Alignment, Indent again.